So we were doing this question illustration number 6, in which we have to find out the area of the shaded region OABE by finding out, hence we have to find out the shaded region. Okay, so first finding the area of this OABE, then after that the area of this shaded region. So as the coordinates of point A, point E, point B and point C are known, so why the coordinates of E are known? Because this is an exponential function of the type e raised to power x. So we can write down this as 0, 1. Okay, this point is 0, 1. All right. So how we can find out the region OABE? By integrating this function, integral of, I'm doing here only, integral of e raised to power x dx from limits x value here is 0 and here the x value is ln 5. So 0 to ln 5, I need to integrate this. Okay, so e raised to power x integral is just e raised to power x. Putting the limits from 0 to ln 5, I will get upper limit as e raised to power ln 5 minus e raised to power 0. E raised to power ln 5 is just 5 because e raised to power log x with base e, right? We're using the property that this property that a raised to power log x with base a is just x. Okay, so here base is e, so e raised to power ln x is basically x, right? So you will get 5 minus e raised to power 0 is 1. So 5 minus 1 is 4. So area of OABE is 4 square units. Okay, then it says, hence we have to find out the area of the shaded region EBC, this blue shaded region. As you can see here in the graph, that O, A, B and C, this is forming a rectangle, right? This length from O to C is the y coordinate, which is 5. So this length is 5 and this length is ln 5, because the x coordinate at point B is ln 5. That means CB is ln 5. So the width of this rectangle is ln 5. So area of this rectangle is 5 into ln 5, right? And from this area of rectangle, we can subtract area of this region OABE to get this area of shaded region. So let us write this. Area of shaded region is area of rectangle OABC, I think, minus area of OABE. OABE means the first part area, OABE, right? So area of rectangle is 5 is the length and height was ln 5 minus OABE is our first area, which is 4 square unit. So 5 ln 5 minus 4 square units. Okay, first part is over. Now its second part says the graph of y is equal to e raised to power x is transformed into a graph of y is equal to ln x. Let me remove these. Okay. So it says that graph is transformed into the graph of y is equal to ln x. Describe this transformation geometrically. So how this y is equal to e raised to power x and y is equal to ln x, they are related to each other, because we know, answer is that we know that exponential function and logarithmic function, these are inverse of each other. And using the property of inverse functions, that if any function has an inverse, both the functions fx and its inverse f inverse x, they are a reflection in the line y is equal to x. Right? Since e raised to power x and log x function are inverse of each other, so that means graph of log x will be the reflection of the graph y is equal to e raised to power x. And I think this we have covered in our chapter number, I think 2, in which we introduced the concept of logarithmic and exponential functions. Both the functions are inverse of each other, right? So how you can describe this is that since both the functions geometrically we have to describe, means both the function will be y equal to log x function will be the reflection of the given function e raised to power x in the line y is equal to x. So let us draw the graph of, let us first draw the line y is equal to x. Let us say this is the y is equal to x line, and the graph will be a reflection of this. As you can see here, this point is A and this point is E. If I write the coordinates of point E, these are 0, 1, because exponential curve will intersect the y-axis at point 1, because e raised to power x, if you write here e raised to power x and put this x equal to 0, it means e raised to power 0 is 1. So this value of y coordinate will be 1. Okay. So if this coordinate is 0, 1, and as we know that if you are taking the reflection in the line y is equal to x, that means x and y coordinates will interchange, right? So corresponding point to this point E will be 1, 0. Okay, so this point A is 1, 0. Not this point A, sorry. Point is, since this length is ln 5, so A cannot be 1. I will write this point as first point as 1, 0, this point. So graph will start from this point and it will be just a mirror image of e raised to power x graph, and I think let us draw like this. Okay, so this is a graph for y is equal to ln x, and it is going, it is looking like that it will come down, but no, it will go to plus infinity. Okay, ever increasing graph, but curvature of this is downwards, right? So yes, this is your graph ln x. Okay, now third part says using your answers to part first and second, or otherwise we have to show that integral of ln x dx between 1 to 5 is 5 ln 5 minus 4, right? As you can see, the corresponding point for this point B on graph y is equal to ln x will be 5 ln 5, right? So if you count these points, this is 1, this is 2, this is 3, 4 and 5. This point is 5. Okay, and corresponding to this point, graph point or the y-axis, not y-axis, the y coordinate will be ln 5. Okay, so this point B will correspond to point, let us say B dash. Okay, let me remove this log x and write the coordinates of this point, this point. Okay, so this is 5, ln 5. Okay, because the point B will get reflected and coordinates will be interchanged. ln 5, 5 will become 5, ln 5. Okay, so between the points 1 and 5 means this area we need to find out. Okay, not the area, basically it is saying that you have to evaluate this integral, right? So how we can evaluate this integral without knowing the integral of log x? Though in further integration, means the next chapter, next to next chapter, you have further integration in your syllabus. We learn how to evaluate the integral of log x, which is derived using integration by parts. But here we do not know the integral of log x, right? Though the question says otherwise. So if you know the integral, it is fine. But I haven't taught yet the integration by parts. So without using the integration by parts, we have to evaluate this definite integral, because it is saying that we can use parts 1 and 2. So let us use parts 1 and 2. So part 1, as you can see, that both the graphs are reflection of mirror images of each other. So whatever is the area value of this blue shaded region will be equal to the value of, or the area below this red shaded portion. Okay, area bounded by exponential curve and y-axis will be equal to the area bounded by log s curve with the x-axis. So this blue and red shaded areas will be equal, right? And how we can use the part 3? Part 3 is, since both the functions are mirror images of each other, and this area will be equal to this area, and using the value of that area which was calculated in part 1, which is 5 ln 5 minus 4. This value we have calculated, which is 5 ln 5 minus 4. So area of the blue shaded region will be equal to area of red shaded region, which is in fact the integral of log x from 1 to 5. Right? This area we have shown that this is equal to area of OABE. Geometrically, magnitude wise, this area is equal, though the functions are different. Okay? Hence, this is area is equal to 5 ln 5 minus 4. Okay? Fourth part says that deduce the values of ln x cube from 1 to 5, and second part says ln 3x from 1 to 5. The basic value of log x from 1 to 5, we know it is 5 ln 5 minus 4. So how we can deduce the values? It is very simple, by using the properties of logarithm. It says that since ln x cube can be written as 3 ln x, because log of x to the power n is n log x. So here value of n is 3. So I can write this as 3 times log x, and if you are integrating this, you can write the integral sign from 1 to 5, dx, and this value we know, which is 5 ln 5 minus 4. So whatever is the answer of your third part of the first part, multiply this by 3, right? So it is 15 ln 5 minus 12. Okay, because this is your first part answer. I hope I made my point clear. And since now you know that these questions are solved using the properties of logarithm, so again in the B part we have to use the property of logarithm. How we can use the answer of part 3 to deduce the value of part 4 B part. So again you will use this, that log ln 3x you can write as ln 3 plus ln x, right, their integral. Okay, this you can write as integral of ln x plus integral of ln 3 dx. Okay, so ln x dx from 1 to 5 is again your first part answer, 5 ln 5 minus 4 with the plus sign here. This is plus sign, plus ln 3 is a constant, you can take this outside, and integral of dx is just x. So it is basically x ln 3. Apply the limit from 1 to 5. So you will write this as 5 ln 5 minus 4 plus 5 minus 4 ln 3 means 4 ln 3. 4 times ln 3. Okay. You can further reduce this to you can write, if you want to combine these logs, you can combine, otherwise you can leave the answer here only. Okay, no need to write the answers or further simplify, because you can simplify log 5 raised to power 5. I don't know what is the value. It is a very big term, because 5 raised to power 4 is 625, and then raised to power 5 is again very complicated. No need to go above those values. Okay, so this is, I found this a very interesting question. That's why I have added this to the video. Okay, so integration of log function is over. In the next video, we will do integration of trigonometric functions using some identities. Okay, see you there.